Good morning, students. So today we are going to start third part of our second chapter. In this part we are going to discuss how to determine the concentration of a solution, which formula will be applied, okay, and then we will study about suspension and its properties. Now, first of all, we will start with one activity. This activity is to prepare a solution. So, first of all, we will take approximately 50 ml of water in two separate beakers. Since we are taking three different compounds, so we can take three beakers. Okay. So in one beaker we will add salt, in other we can add sugar, and in third we can add barium chloride. Okay. Now then what we are going to do, we will continuously keep on stirring, okay, and then we will obtain a particular solution. A stage will come when we cannot add more solute, okay. That stage, at that particular stage, the solution will be termed as saturated solution, okay. Now we want to see that if we heat it, then is there any change or no, okay. So what we will do now, when we have got saturated solution, then we will heat that solution and we will increase its temperature by 5 degree. Now again we will start adding the solute. It may be salt, it may be sugar, or it may be barium chloride. Then what we will see? We will see that now we are able to dissolve little more amount of salt, okay. So what it suggests? It suggests us that if temperature varies, then formation of saturated solution also varies. The amount which can be dissolved, that may change. It may increase with the increase in temperature, okay. Now see, this slide is for just seeing how the substances look alike. Salt, this is salt, okay, and these are sugar cubes, and this is sugar, okay, and this is barium chloride. It looks like salt, okay. Now we will keep on mixing the things, and then what we will get? We will get a saturated solution, okay. Okay, now see, when you look at this picture, then what you can observe? You can observe that there is some dissolved solute also, and there is undissolved solute also, okay. So this is a dissolved solute and this is undissolved. So this particular solution, this which is upside, we can say that it is saturated solution, okay, because we are not able to dissolve more solute in it, okay. Now a term comes, solubility. So what is solubility? This we are going to discuss in next slide. So from this activity we can come to know about the fact that if I am taking different substances, then different substances will have different solubilities. Means if I can form salt saturated solution by mixing 3 spoons of salt, then it will not be the case in case of sugar. Its amount will be different, and same will not be true for barium chloride. So it means that if we want to prepare saturated solution of different compounds, then their amounts required will be different, okay. So this is what this activity suggests. Now, is the amount of salt and sugar or barium chloride that can be dissolved in water at a given temperature same? So it is the same thing which just now I discussed. So what is the answer to this? That amounts of different solutes will be different for formation of saturated solution. Okay, so this is the answer to this question. Now, at any particular temperature, a solution that has dissolved as much solute as it is capable of dissolving is called saturated solution. So what does it mean? That if we are not able to dissolve any further solute in a solution at a particular temperature, then we will say that this solution has become saturated solution. Okay, now the term which I just discussed, solubility. What is solubility? The amount of the solute present in the saturated solution at a particular temperature is called its solubility. Okay, now temperature is very important here. If we will change the value of temperature, then solubility value will change. If I increase the temperature, then solubility will increase. What does it mean? It means that more solute can be dissolved in the solution. And if I decrease the temperature, then solubility will decrease. Okay, so this is very important, which you must remember. Now the two more things come. Just like we said saturated solution, one more term comes, unsaturated solutions. And is there any effect of temperature? This is just now we discussed. Now, if the amount of solute contained in a solution is less than the saturation level, then it is called unsaturated solution. Okay. Now, the question is, what would happen if you were to take a saturated solution at a certain temperature and cool it slowly? So, what is the question now? Question is that if I take a saturated solution, say it is at 25 degrees Celsius. Now what I do, it is saturated solution, so I cannot dissolve more solute in this. Now I take this solution and start decreasing the temperature from 25 degrees to 20 degrees. Say I have decreased the temperature and it is now 20 degrees Celsius. So what we will observe? Now since solubility depends on temperature, when temperature was 25 degrees Celsius, at that time solubility value was more. Now temperature has decreased, so solubility value will be less. So what does it mean? It means that that amount which is dissolved in this solution, which is extra, that will start settling down. Okay, so what you have to remember? You have to remember that solubility is temperature dependent. So if we decrease the temperature, then extra dissolved solute will start settling down. It will settle down. Okay. Now concentration word we studied in the last session also. So how can we calculate the concentration of a solution? Okay, in general, if we don't want to write the whole word, whole spelling, then we can write like this also, CONC dot. Okay, this also represents concentration. Okay, now see, what is concentration? It is the amount of solute present in a given amount of solution. Okay, so when we want to calculate it for a given solution, then there are three ways. Number one, mass by mass percentage of a solution, mass by volume percentage of a solution, and volume by volume percentage of a solution. Now see, from the name itself it is clear that what is to be done. In first case, we have to take masses of solute also and of solvent also. Solvent or solution. Okay, similarly here we have to take mass of solute and volume of solution. Similarly, in this case we have to take volumes of solute also and solution also. When I say solution, then it means volume of solute plus volume of solvent. Okay, because solution is equal to solute plus solvent. Okay, now how to use this and what are the formula? Okay, so the formulae used are, the formula is singular word and formula is plural word. So since there are three, so we have written formulae. Formulae used for calculation of concentration. This means concentration. Now first is we have to divide, in all the cases we have to divide solute by solution and we have to multiply with 100. Now if it is mass by mass percentage, then we will divide mass of solute by mass of solution. If it is mass by volume, then we have to divide mass of solute by volume of solution. If it is volume by volume, then volume of solute is to be divided by volume of solution. So from the name itself we can easily remember what is to be done. Now let us understand this with the help of one example. So the question is, a solution contains 40 gram of common salt in 320 gram of water. So mass of salt or mass of solute is 40 gram. Mass of solvent is 320 gram. Calculate the concentration in terms of mass by mass percentage. Now since masses of both the things are given, so we will apply the formula mass by mass percentage of the solution. So we need to know what is the mass of solution. Okay, mass of solute is given, mass of solvent is given. So mass of solution will be mass of solute plus mass of solvent. So we get mass of solution as 360 gram and mass of solute is given, it is 40 gram. Now we will apply the formula mass percentage of the solution is mass of solute divided by mass of solution into 100, and then we will get the value as 11.1%. Okay, so whatever data is given to us, on the basis of that we can check which formula is to be applied. Now next thing comes, what is a suspension? Okay, now see, till now we discussed about solutions. Now second type of system comes, which is suspension. Now very first thing is, suspension are non-homogeneous systems, okay, in which solids are dispersed in liquids. Okay, so when we have to make a suspension, then it is compulsory that solute should be solid and solvent should be liquid. Okay, so suspension is a heterogeneous mixture in which solute particles do not dissolve but remain suspended throughout the bulk of the medium. Now what does it mean? It means that in case of suspension, the particle size is higher. Okay, because of higher size, they cannot be dissolved easily. So when they cannot be dissolved, then they will remain suspended, they will remain in the suspended form. Okay, and since their size is more, so we can see the particles of suspension by naked eyes. Okay, now let us discuss the properties of a suspension. Now see, in this diagram you can see this is a suspension. In most of the cases, means suspension, if we take as medicine, then in such bottles it is written shake well before use. So what does it mean? It means that its particles have settled down and you need to shake it properly so that the dispersed phase particles can mix in the dispersion medium. Okay, so that solid which is being distributed throughout a liquid solvent, those particles can move throughout the sample and you can get the mixture. Okay, so what are the properties? Suspension is heterogeneous mixture, very first thing. Second, particles of a suspension can be seen by the naked eye. Okay, so particles of suspension can be seen by naked eye. Third, the particles of a suspension scatter a beam of light passing through it and make its path visible. Now what does it mean? It means suspension shows Tyndall effect. In solution also we did Tyndall effect. Solution particles do not show Tyndall effect, but suspension particles show Tyndall effect. Okay. Tyndall effect is scattering of light when light passes through suspension. Okay. Now solute particles settle down when a suspension is left undisturbed. So in case of solution we did that if we keep the solution, that will not change, there will be no change observed, but if we keep the suspension, then the particles which are distributed, they will start settling down. Okay, so we can say suspension is unstable. Unstable means the way we have prepared it, it will not be in the same way, it will change. Okay, now since the particles are heavier, so we can separate them by the use of filtration process. Okay, so these were the properties of suspension. Now whatever we have discussed, on the basis of that you have to solve these assignments. Okay, thank you.